RobMech was born out of a conference which started out 6 years ago, the Advanced Robotics and Mechanics Research Network, where universities would get together to share ideas and research. RobMech is now in its 5th year. At this year's conference, there was a strong mining trend amongst the robotics featured at the event.
There is a strong mining trend, and I don't know whether I must take credit or blame for that. I work for the CSIR and the Centre for Mining Innovation, and that is my strategy, is to publicize mining robotics and the golden opportunity that it presents to South Africa. It's my belief, and I've been working hard for 3 years to elevate mining robotics. And talking to all the universities, I don't believe South Africa can compete internationally with, for example, Japan on humanoid robotics, or compete with the US in terms of military applications in robotics. But mining robotics is a unique South African problem, and it's a very unsafe environment in the South African mines. Nowhere else in the world do we have mines like that. So we need to develop the technologies that we can implement ourselves. We can leverage relationships with international organizations because they do know a lot, and we can adapt that to application here in South Africa. So there's actually a mining robotics session going on now, but the conference isn't focused on mining robotics. It's just that section. We've got an education session specifically looking at robots for education, going from primary schools, low-cost robotics. We've got a gentleman from Zimbabwe looking at what type of robotic platform is needed for the African environment, where we're not flooded with money. We don't have €7 million projects. We can't play in that arena. We've got a mobile robot session, all the projects dealing with robots that move around. And then this afternoon we've got machine intelligence and control session.
Mining companies invest millions in researching safety in the mine working environment. Anton Voigt works for DebTech, the technology division for mining company De Beers. They took on a project to see what they could develop in regards to a safety technology with a limited budget and 100 hours of research.
We just wanted to see what's out of the possible. Like I said, it's more of a lunchtime project. It's not an official project. We probably wouldn't launch into fully developing this. It's more to explore the technology area. So now we know what's involved in developing something like this. It makes us wiser when we are procuring something like this from a supplier. It definitely has a lot of value in terms of show and tell, but where the paintball gun concept came from is that the one application area that after blasting an area in the mine, before sending people in, you might send an autonomous vehicle in to identify dangerous areas. Once it's found these areas, it needs to mark them in some way. So the paintball gun would then be, in this case, that's what the paintball gun does. It finds, say, a place where there could be a potential rockfall. It marks it with, say, some luminous ink, and when it comes out and people go back in, it's quite easy for them to see where there's potentially dangerous areas.
Matthew Price has been building sensors for a new mine safety robot that CSIR is developing.
This is based on trying to make safe hanging walls in mines pre-blasting. Normally the miners would have to go in and prod the roof with a big bar, and this is quite dangerous, and the mine safety robot is designed to try and assist with reducing the risk of risk to bodily harm of miners. The sensors we're looking at are a thermal imaging camera and a 3D sensor based on the Microsoft Kinect. And how this works is we capture 3D data of the mine roof, we take thermal information and we superimpose that on the 3D. Where the roof might be loose and the surface structure is flat, that could indicate a loose rock by a low thermal gradient. The reason is ventilation air that passes into the mine cools the mine, but if a support or a rock is sticking out, it cools preferentially, so we can't actually assess risk on those parts. So this is a first step in identifying risky points by identifying low thermal variation or high thermal variation in these flat areas. So that creates a map of risk. We then have a tapping device, and the tapping device has an arm on the robot that will go out and take an acoustic sounding to see and confirm whether the risk point was risky or not.
Jeremy Green says South Africa has still a long way to go to catch up with some of its global counterparts, and that there's a lot they can take away from what others are doing in the industry abroad.
There are some domains where South Africa is in line with the rest of the world, but there are some domains where we're woefully behind. And there are times when I sit back and I have a beer on a Friday night and I think, what am I really trying to achieve? When you can go to a university like Carnegie Mellon, who's been involved in the Google car, and they have a vehicle that can drive around an area or a road without a driver. You can sit in the back of the vehicle and get to work, because there's no way that we can do that. But then in the same breath, I think there are applications in South Africa that we need to tackle, and robotics can make a difference there. And that's where we need to strive and focus. And by building relationships with international researchers, we can take the excellent work they've done and apply it to our unique situations. And that's still research. You don't just see the red car that looks nice and paint your car red. It's not as simple as that. We need to take the algorithms for the Google car to make sure that it doesn't hit people. And we need to do a fair bit of adjustment to take that intelligence and put it onto a mining vehicle and make sure that a mining vehicle in a tunnel doesn't bang into people, because that's the second biggest killer of miners in South Africa, is interactions with a vehicle, a mining vehicle, that results in a fatality.